And there we go. Hey, what's up, everybody?
Welcome to a overexposed episode of
Why does that always happen?
3D Thursday, Wirecast, or no.
It's weird.
Webcam
settings.
C92.
Anyway, happy Thursday. Happy 3D Thursday. I've lost my train of thought.
My coffee is warm. Our prints are finished. We got another week of 3D printing news for you guys.
Pedro's battling the sickness.
I'm battling the plague.
He has allergies. Anyway, welcome everybody in the chat room. Thank you guys for joining us today. This is, of course, 3D Hangouts. You're about 3D printing, DIY electronics, smash them together, blah, 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 blah. I think that's
inspirational projects to help you along.
It's all right, man. People know by now.
Endeavors. I'm Pedro, creative tech here, Adafruit.
The hat says my name. Let's see. Looks like today's coupon code is 3D doll.
That's right. This week's project is prosthetics for an American doll.
Yeah, this was something that we got inspired by. So earlier June of this last month, Courtney Bennett.
Hello.
She has a daughter named Emma, who has who's an amputee, and they work with a company to make a prosthetic to customize an American Girl doll. Yeah, so these dolls are a big deal to little 8-year-olds and stuff. So
yeah, so everybody saw the video that Lamar was thinking, it would be cool if parents, didn't have to go to their prosthetics company to actually have this done for them. And it involves like chopping off, the limbs and it's pretty thick plastic.
It's surgery, man.
So she was thinking, why don't you guys model some limbs that you could easily have printed out, like at Shapeways or
3D
hubs, or if you have your own printer.
Local 3D hubs.
Just print it out. So that's what this week's project is. One of those inspirational projects which hopefully gets children to think a little bit. Children and parents to think that they have the power to definitely build their future and their bodies and how they want. So take a look at this week's little CAD tutorial on how to actually make the hands for this.
Yeah, Pedro put that together right before this show. There's that one's overblown.
Some little close-ups of the arm. So we're doing the. Actually, no, you took this inside of Fusion or inside of Mesh Mixer and did the little Verneuil.
Right, that was after. That was just to give it this cool effect. So Pedro, you modeled. This is kind of your first attempt at modeling a human hand, modeling a leg inside of Fusion. And before you went with the standardized prosthetic leg, you actually remade this leg with curvatures and all the little organics that go with it, all the contours that go with it.
You threw it away, yeah.
You threw it away. You recycled it.
I recycled it, yeah.
Because it was just sort of like a training exercise for you so that you could get more familiar with the free-form modeling tools in the sculpting environment inside of Fusion 360.
Yeah, so the first time I actually used it was for the Halo
and that's very
gun.
It's more of like an object. This is more of, matching the contour of like an actual human form. So the hand is actually pretty neat as you've modeled.
Can still hold accessories
before in polygon environments like Maya. That's sort of where you learned, like in college. That's what you learned was Maya. Mm-hmm. So what was it like to model this in Fusion? Was it easier, harder?
It was pretty much the same. If you jump into the screencast.
Do you want to jump into the screencast?
Yeah, I don't know if you had time to actually put that in there.
No, I did.
Cool.
It's right here.
So we're using the sculpting environment inside of Fusion to create this. So I just clicked on the box model, and if you haven't been in the sculpting environment, definitely check it out. It's a nice way to make very nice organic models. So for this example, I'm just making a 10 by 10 mil box, and it gives you these little handles that you're able to adjust the subdivisions for that.
Cool.
So you can just scrub these left and right to add and remove. So for making the hand, we just made 4 little subdivisions there for each finger. And then the thumb is actually going to be extruded out of the bottom.
Or the side, no?
So in school, we were taught not to do it in the side. For rigging purposes, you actually want to extrude it from the bottom. And that's so that you have the pinching. You just click on your extrude for each limb.
I thought you were extruding from the top, so you're doing it from flat down. Okay, cool.
Yeah, it doesn't matter which way you do it. But yeah, the longer way is where you want to extrude it from. And you can type in there your face count. I actually should have added 3 instead of 2, since we have 3 sort of sections for each finger. Yeah.
Cool. So, but just look at it just like how your finger is. Okay.
Yeah, but you can always go back in there and subdivide again. You can add more divisions for each one.
Cool.
And when you extrude each section, it'll remember what your last settings were for that, and you can just type in the number for that. And this is what I was talking about for the thumb here. Mm-hmm. You extrude it from the bottom, and then you just go in there and mold each.
It's like the palm of your hand then?
Yeah, you can mold the palm. You can go in there and refine each finger.
Yeah.
And then you can move your pivot position and start rotating that around. And again, this is completely editable, so you can go back in there and change things. And then start extruding from there is how I actually moved on to create the arm, and just started extruding from there to create the rest of the limb. You can just wind up with something like that. So it took about a day to completely, just looking at my arm, seeing where all the curvatures were, moving these subdivisions around so they matched up to where each curve for the arm was. Okay. And it was quite fun. It's like modeling with clay.
Yeah, it is. So there's a lot of pulling and pushing and double clicking to get your edge loop right. Mm-hmm. And then the challenging, not challenging, but maybe it was challenging, but making it hollow, did you just throw a shell on it, or did you have to do any specific cutting tools?
So there is an option in there to make it hollow. Okay. And that's what I had to use for that. Cool. Excuse me. Still battling over here.
Yeah, you'll hear you coughing. We apologize for that. So as far as support material and orientation for 3D printing, optimizing for 3D printing.
Yeah, so for the arm, I did have to use a lot of supports because I didn't want to have to, print it.
That's not too much.
On the bottom there like that. The one trick though, oh man, this is going to be difficult.
Yeah, poor Pedro.
Can you go over this?
Yeah, I'll go over this. Let me move Pedro. He's dying over here. So he added a 6mm brim because it's like a perfect curvature point, kind of like that. So he added a giant brim, and then for the actual supports, this was created in Simplify 3D. He used a density of, I believe, 4 or 8. Okay, 8. This is like making charades now. So there was a certain way that you had to orient the pillars, the support pillars, because you can draw your own. So this was all custom sort of drawn. You don't want to just like throw an auto-generate one, because then it'll throw stuff everywhere. So you just kind of strategically put them in place. And there's a special order that you did so that you get this sort of zigzag pattern here. So you see how the pillars come here, and then they zigzag, and then they come back in there. Can you explain that part yet? Are you good? No?
I'll try. What was the question?
Oh, man. He's really messed up. Just cough it out. Let it out. Give us a second, folks. We're going to mute.
No supports needed on the foot.
Okay, no supports. Poor Pedro. No supports on the foot because it's a flat foot, so it prints straight up. It is a bit tall, so we actually needed the extended Ultimaker 2 Plus, which is, I don't know, I think it exceeds 200 millimeters. Is that correct? 250?
Yeah.
250? 300?
No, it's like 2.
Poor Pedro. Never mind. Don't try. It's like about, I don't know, 250. This wouldn't fit on the regular Ultimaker, nor the Flash Forge. It probably would fit on something like a Type A machine since it has a 305. So I think it's in between 250 and 205. I didn't design this, so I'm not sure. Sorry, but it is hollow as well. These needed to be hollow so that we can fit in those suction cup things that hold it in place. So I mean, if it's something you guys want to try out, more than likely you're more than free to remix the design.
It's definitely for like making toys and things like that.
Sure, if you want to make toys or something like complete from scratch, I guess it's a good. The form tools are really the way to go to make these organic forms.
Cool.
I think that was it. Thanks for bearing with us, folks. If you guys have any questions, we'll answer them shortly in the Q&A segment. Pedro's going to do some tweeting, and I guess I'll answer some questions right now if I see any. Get Pedro some tea. He's got coffee, just kind of like tea. Yeah, I need that technical difficulty screen. Kirby is saying, and now John is coughing too. Sorry about that.
A little bit better
3D
now.
scanning. I think somebody mentioned can you do 3D scanning?
So with the size of how big these guys are, we probably need like a pretty expensive scanner to scan these.
What about the Kinect?
The Kinect? No, it's. I forget what the size limit is on those, but you need something that's pretty big. Yeah, you can't get too small.
All right, we just know from experience, I guess. It's been a while, but... And then something like 3D Catch, it catches some low resolution, so it wouldn't be...
Pretty low res, yeah.
So you took measurements, I'm assuming it.
Good old calipers, and then just looking at it was the way to go for this
diameters and just height and width.
And just prototyping, making sure the sockets all fitted inside the torso.
All right, I think that's it for now. Cool. Oh, I'll talk about that next, actually. Somebody's asking, what is the watch I'm wearing? It's probably this one you're wondering. It's like, what is that? We're good with the doll. Oh, real quick, folks, it is up on the learning guide. We made a guide of how to do it. So there's a little bit on the CAD stuff, on how to adjust it, like the length of it and stuff, how to set it up in Simplify 3D. And just the parts list, or the parts list.
Yep. If you ever find yourself needing to do this for someone, instructions there on how to set up the assembly.
Cool. People were saying it was creepy, and she came alive. She died and became alive.
It's quite educational for kids to know how toys are made.
Yeah. No, this was cool. I mean, it is using the sort of socket, the elastic string type method.
Yep.
Cool. All right, just throwing it out there. It's up there, and files the STLs as is are on Thingiverse. And I don't know, but is the Fusion 360 file up too?
Yeah, that's up there too.
Sweet.
Actually, that's a little secret there. If you ever see these the guides go live before Thursday, the Fusion 360 files are the first thing that goes live. The Thingiverse usually wait around until Thursday to launch everything as one pair.
Great. All right, thanks, Pedro. Cool. So what I've been working on is this guy here. This is a custom PCB that I designed in EagleCAD, which is now owned by Autodesk. So I sort of got the idea from this project on Tindy. It is called a strap-on, which is basically a wearable proto board, like a prototyping board. I like the concept. It was a circular Proto, a breadboard. But it didn't look like the traces, or there weren't really any traces, just straight through hole pins. So what I thought would be cool is to make it more standardized, like a real breadboard. So it has power rails here, and then it has your standard 15 across and 10 down, and then separation in the middle, just like a real breadboard. If you've done any breadboarding, you'd know how standardized it is. So what I have here is a little 3D printed NinjaFlex sort of bumper, and then this sort of strap here, and this is where I keep the LiPo battery. And the way it's strapped is like your standard like nub and holes. So you just snap this nub into the hole, and this sort of tucks into this little part here. And I'll talk about it more. I actually want to do a layer by layer on it. So right now I just have a Trinket microcontroller. It's like 3-volt one. I have the LiPo backpack, which it's actually for the Pro Trinket, but it also works with the regular Trinket. And what this does is it allows you to use the micro USB from the Trinket to actually charge the LiPo battery. So that's pretty neat. And then I just have a button, a slide switch, and 2 breadboard NeoPixels. So I'm just running the button cycle demo code that we have as a part of the NeoPixel library. So it just cycles through some different colors. There's like super bright, and then here's sort of the rainbow. So there's a lot of different projects that I'd like to use this PCB for. Since it is a breadboard, I can put all sorts of different circuits on there. So one of them is to, if you guys look back, way back, one of Adafruit's first projects, before it was like, I don't want to say huge, but the TVB gun is something that uses an IR LED and a tiny 85, or a tiny microcontroller that lets you turn off TVs. So that was a really big and popular hackery type project. And we still have the TV Be Gone kit in the Adafruit shop, but you can use a trinket, and if you modify the code a little bit in those IR LEDs, it'll just blast a bunch of different codes to your TV, to the IR receiver in the TV, and it'll turn off the TV. So that was one of the things I wanted to try out. I just got the IR LEDs, so I'm going to hack around and see if I can get that working so I can turn off TVs. That would be kind of cool. So that's the project. This was, of course, milled on the other mill. And here's how the bumper works. Because this is so long, you could, I was going to 3D print this in one piece, but because the bed isn't, maybe you have like a 100-millimeter bed, these straps right here just actually thread through the little hole. And you can see that the PCB, let me turn this off real quick so you can see it. The PCB has a hole there. So there's a little slot there. So that's a part of and then you can probably use regular NATO, or was it NATO? NATO wristbands. Mm-hmm. And then this just gets inserted this way. And then there's a little rubber stopper here. So you can see the stopper. It's thicker and wider than the slot, so it gets held in place like that. And it is, of course, elastic because it's NinjaFlex. But you could print this in other types of Filaflex or Semiflex or Ficaflex. There's so many flexes. And yeah, there's quite a bit of room here for other components. If you guys remember, one of Becky Stern's projects was a haptic wristband. It was called the Mindful Bracelet, and it basically just had a small little vibrating disc motor, and it would vibrate every interval. So maybe every 10 minutes, every hour, or something. Whatever you want to change it to, you can do that. And it's just so that you can feel the passage of time as opposed to hearing it or seeing it. So it's kind of like a neat little wearable project. So this is also a good platform for that. One of the first prototypes I made was this guy here, which is a little bit smaller. I didn't have it. It wasn't standardized yet. I have the power rails, but they're kind of going in the opposite direction. So you can see this one's more like the power rails are on this side as opposed to going up and down. And this one just has a little coin cell holder, little Adafruit coin cell holder with a slide switch, and then resistors and LEDs. No microcontroller at all. And so you can just kind of make it as an art piece too, just to wear this little art piece. That's kind of cool. The back, of course, you don't want to wear this with an opening here because then you're going to scratch up your wrist. So that's why I have this completely covered. But I like having it exposed so you can actually see the electronics, and the edges is nice and covered and bumpered so that it doesn't hurt anybody. It isn't waterproof. I mean, maybe it's waterproof if you put Never Wet on it. But that's the sort of project I've been working on. Wearable, yeah. Ultimately, I'd like to get this. I'd like to send this design to Oshpark, and then add some nice screen graphics because this is kind of finicky. This copper can oxidize, and it's kind of easy. Not easy, but it can break under stresses because it's a really thin piece of copper. So a solder mask would definitely help out, and sending it to Oshpark is probably the way to go. And if there's any interest, we might manufacture it and sell these as sort of just wearable proto boards. We have a lot of proto boards already in the Adafruit shop. We have a half size, quarter size, and a full size breadboard. So I think
missing a wearable one. Yeah,
you're just missing a wearable one. So that's about it.
And of course, you'll release the file. So if anybody has something custom that they want to adjust on there, they can
super easy.
Move the traces around.
Yeah, and make your own traces.
The other way,
yeah. Cool. So, TV Be Gone Wearable Edition. Yes, that is exactly right. Sounds good, yeah. Cool.
Yep, just got the IR LEDs yesterday, and so start prototyping that up over the weekend.
Cool. Good pages to cool. Frequency Bender. Welcome to the show. You're just tuning in live. Cool. All right, that's all I got.
Next up, we have...
I have another Wearable layer.
Oh.
So Andrew Stott has a new printer, and he was telling me, hey, it's kind of hard to set up a dual extrude profile for a printer that isn't sort of supported in Simplify 3D.
Through the wizard.
Through their wizard. So let me show you guys real quick how to set up a custom profile. This may or may not work. Because I don't have a
non-supported printer.
Yeah. But here's what you would do. So this is the D20. Obviously, you align the models in that drop down that I just showed you. Maybe it's too quick, but here we go. And then under tools, there's the dual extrusion wizard. So I would work off of an existing profile. So probably one of the standard ones is the FlashForge Creator Pro, because the Sigma has the parking head. That one's a little bit special. There's not a lot of other printers that do that. But a lot of the dual extruder printers are kind of like the FlashForge Creator Pro.
It's all in one head.
Yeah, it's all in one head. So you can change your color options around. So you say, just be aware of which extruder has which color. If it's important to you, then you need to set that accordingly. Once the STLs are grouped in the STL window, you can then lay it flat on the bed or move it wherever you want. I used Control L to pick a triangle so that it flattens it out onto the bed, because right now it's on an angle there, on a little edge. So where you want to steal stuff is under the scripts tab, and then in the sub tab starting script. You'll see that there's some special stuff that the nozzles will purge. So there's a certain code for purging the left nozzle and then the right nozzle. So you'll really have to kind of study this and add these to your custom profile. So, but most of the commands do have comments, so you can just read it and understand. If you don't, you can always look it up on, I think, Merlin's firmware or the RipRap forums. And then there's something in the end script, so you just have to kind of be aware of those.
Retraction script as well.
Yeah, I looked on, there's nothing in there. So
I thought tool change. Sorry, tool change.
I think tool change, yeah. So be sure to check all those tabs, and there's nothing there, but it should be there. But
yeah, something should be there.
Yeah. Well, yeah. So anyway, once you figure that, once you get your G-code stuff out of there, then you can start modifying your profile. So let me hit cancel, and then this is where I believe I change or delete it. Yeah. So yeah, you're just gonna make sure that your G-code scripts are set.
And one thing I like to do too is because it's not intuitive here, where it says color 2, color 1. I change that name. Yeah, I change it to tool 0 is right or left. Tool 1 is left or right, just so that I know. Because when you hit preview your tool path, it only tells you, in the colors, it only tells you tool 0 or tool 1.
Okay, so here I am. I set up a PrinterBot Play profile. Let's say I have a dual extruder on the PrinterBot Play. I create a new extruder, and then I assign it as tool 1, because tool 0 is your left and tool 1 is your right. So then create another profile, and then make sure you select the extruder that you want. And you might also, just to avoid some confusion in each profile, delete whichever thing. Oh, and then group the profiles so that they're grouped when you export it out. Then you can use the select models button to select the model that you want, because you can't use the dual extruder wizard. I only use the dual extruder wizard as a reference point, so that's kind of why I did that. It's still a little bit confusing, guys. I mean, it's sort of unintuitive. It really is. Dual extrusion is still one of those things where I can mess up sometimes. So you really are going to have to trial and error on it.
Yeah, they still have some improvements that could be added, like when we're doing ooze shields. It'd be nice if after a certain amount of layers, it would just not do any more an ooze shield. Case in point, when you're printing something like that's only 20 layers high, I don't really need the ooze shield to continue to be printing, because the second printer is not gonna keep printing again. So I don't need the ooze shield after that. So that'd be nice, and if in a future release of Simplified 3D, it was smart enough to know, okay, after 20 layers, the second extruder is no longer going to be used. So stop the ooze shield at that, or give the user the ability to say how tall the ooze shield's going to be.
Yeah.
and other things that you can manually do is I had a clog earlier because after the 20 layers that it prints, it just sits there. The second extruder sits there with the heat on, and it just sits there and sort of melts and makes residue inside the
that
heat
can
break.
Cause some problems later on.
So if it was smart enough to know, okay, after the 20 layers, it's not even going to be used anymore.
Yeah.
Shut off the extruder after that.
Yeah.
Don't make the ooze shield any higher. But
that's some trickery there, because G-code only knows what to do so much.
Yeah.
Good luck, Andrew, on it. You definitely need to do some testing. If you guys have any if you have any suggestions, please offer them up in the video, in the comment section, because that's one of those things where it's very specific, for people who have the printer that's there. And then I think you could suggest a printer to Simplify 3D, right?
Yeah.
Because they have to do some testing against it. They have to get it in house maybe and write some custom G code.
Yeah.
For the start scripts and the layer change.
That's why this software costs money, because you need.
I think you get that sort of
research
support. Yeah. Cool. All right. Well, that's what I have. It might not work, so I don't. That's just one way I think it might work. So, all right.
And next up we have.
Coupon code is 3D doll. If you guys want to pick up the filaments or anything.
Filament printers, and of course all of the lovely
NeoPixels,
boards
breadboards,
that you saw on this.
breadboard NeoPixels. I haven't played with breadboard NeoPixels. They're pretty nice. I was only able to fit 2 of them because they're a little. If you look on the product page, you can see that you're supposed to put it in the middle of the breadboard, because if you have it going across, then the in and out will be on the same trace line. So I actually had to cut one of the traces. You have to be kind of wary of where you place your NeoPixels. Anyway, you can also set the extruder temperature to change after a certain layer.
I was about to say that, but I didn't want my throat to hurt anymore. But yes, that is exactly what I'm going to do.
Good point, Kirby.
I had to spend a lot of time unclogging that in.
Yeah, you did. Yeah, we used what is it? Wood fill, not wood fill. Cork fill. That clogged our nozzle yesterday, and it took a good couple of hours to clean it out. Okay, thank you, George, for the lovely comment. How many hats do you have with the 3D printed stuff? I have 3 hats. I want more. I have a black one, a brown one, and a gray one. Today is black.
Okay, next up we have more 3D printing.
Oh my goodness! Layers. So let's talk about Shop Talk. Let me do the thing here. All right, so Shop Talk, folks. Oh man, have we been messing with? Oh yeah, real quick. Here's a quick video of me milling the thing out. I'm all over the place. Sorry about that. Any questions about the other mill? It's faster. This is the other mill Pro. It's faster. This is a double-sided FR1 board. It took about maybe 2 hours to do, because I had to do a tool change. I'm using 2 different tools, a 132-inch tool and a 164-inch tool. And there's a lot of pins, so there's a lot of milling. So it took about 2 hours to do. And then I flipped him, because although it isn't through hole, it isn't like a plated through hole, it really doesn't matter. I just wanted to both sides, because I like to test out the accuracy of the 2, and it came out really spot on, so that's good. All right, moving on. That's it.
So our continued testing on getting 175 millimeter to print on a 3 millimeter printer has turned out to be successful.
Yes, so this is the Sigma from BCN3D Technologies. Y'all know it's a 3 millimeter, 2.85 millimeter printer. It's got the dual parking heads.
And I have a habit of taking 3 millimeter printers and turning them into 175. Did that with the Lulzbots, the Ultimakers, and now the BCN3D.
All right, so here we go. Pedro last week talked about how he sort of alleviated some of the issues we were having with the BCN3D, adding thermal paste to 2 different types of threads. So that was what we talked about last week. And that was just to get our printer dual extruding properly. We showed off the print, the NPR print that was really good. And now Pedro's next adventure is, can I get 175 filament? Let me say, why do you want 175? We're we kind of have a reason to. We have a lot of 175 filament. I just ran out of coffee, and I'm running low on the conductive PLA from Proto Pasta.
Which
this
we
is all
found
3mm stuff.
In this case, we found that the 3mm wasn't as good as the 175.
It was very
this
brittle.
Is coming from the same company. You know, I figured the same extruder, just a different nozzle that's doing the extrusion. So the properties were totally different at a thicker diameter.
Yeah.
And we've confirmed, heard Kirby say that it was more brittle, where it was, as we saw with the 175, it was super flexible for us.
Yeah.
So sometimes the 175 is a little bit better in terms of the properties.
It's different. It really is different. It's not just physically material property different.
It tangles a lot more.
Yeah, a little bit more tangly.
It's a lot more harder to, because when it's wound up in a spool, it'll form that curve. So it's harder to, sort of bend that out of shape when you're just trying to pull it through the feeder.
All right. And again, we have a lot of 175 filament, so it is our interest.
It's a plus if it's able to print both 3mm
awesome.
and 175.
Yeah, I mean, what printer manufacturer says, oh, we could do both? Not really many. And when we asked the guys at BCN, they're like, no, it's not possible. Well, Pedro figured it out. Let's roll the B-roll.
It's actually a pretty simple way to do this.
Take off the filament.
After I went through like a
Step
whole
one.
spool.
Step two.
So the way to take the feeder motor out of the BCN is these two little, I don't know the size of the hex nuts for this, but just take first you want to remove the plate that has the motor driver behind there.
Okay,
so
that's where she's hiding.
Unplug the motor,
All right.
And just unplug that guy there.
It is a spring-loaded. It has two Bowden tubes, one
on the inside
underneath and one up. Usually you just have one Bowden tube, but this one's a little bit special. It has two.
Yeah, just because of the spools are on the inside.
Yeah, this spool throws underneath the printer and then up into...
Yeah, so this is the main culprit here, is this one bolt that is holding the mount onto the motor, which isn't even really needed because the other three provide enough stability for the spring-loaded mount on there. So after you remove these three screws, you can have access to that. And you're going to need to know how to do this anyway. If you ever have filament grinding in there, you're going to have to clean it up. They recommend doing like it every month or so.
Every month?
And, every month or two, but...
Depending on how much you print.
Yeah, exactly.
If you print every day, then yeah, every month.
So yeah, that little screw that tried to run away from me right there is the main culprit. It was blocking how far the spring arm was able to grip on the filament.
Okay.
Yeah. So after I did a little bit of cleanup here, and I'm just using a little small brush.
Ooh, it's even dirtier over there on the
there was
bearing
just everywhere because
because we were having that problem.
The thermal paste, it would cool.
Yeah.
And it would just grind everywhere. Yeah. So you want to be able to clean all that.
This is all conductive PLA.
Yeah. So go ahead and clean all that stuff up. Get all of the grooves in between the gear teeth.
Take a photo reference so you know the orientation of where your wire is.
Anytime you disassemble anything, you want to have photo references. So,
all right, cool.
Make sure that.
So just put it back on.
Put it back on, and these are just the 2.5 mil M screws.
Okay.
And as we put everything on, you can see that the bearings all line up, and this is where the screw would have been. And you could see right away that it already would have blocked it. Yeah. And if you look at the grub screw that adjusts the tension of it, it wasn't even in all the way.
Yeah.
So even with it loose, it was already blocking how far you were able to grip onto that filament.
Yeah.
So they're going to recommend screwing it until it's flush and then screw it in 2 more times, and that should be a perfect tension for 2.85. And what I found after you remove this screw is perfect for 175 as well. So after you do this, you don't even have to adjust anything anymore.
Physically,
Yeah, physically. And there's no, you don't have to use any different gear teeth, which I was planning on doing, but I couldn't remove the gear because the little grub screw that holds it in was completely stripped.
Okay.
So,
put it back.
Good thing though too, because that would have been another variable that would have sort of, I don't want customers going there and have to switch out your gear tooth just to have something work. But yeah, this is something that we're going to totally suggest before we stock any of these is just don't use that that bolt in there. So it's a nice bullet point that you'll be able to use 175 and 285 without any adjustments at all. And I know people are going to come out of the woodwork and say, "Oh, you have to use a
PFT tube. This doesn't. Does this actually work?" Well,
let's go ahead and print something that a lot of people had trouble printing. This week's Time-Lapse Tuesday was the little penny piggy bank, which a lot of people said they had a lot of troubles with. Well, guess what? All the retraction that's going on, you can take a look here. This is
look how thin that is. Look at that skinny filament. So skinny.
Absolutely no problems printing a completely Verneuil object with 175. The retraction on this was 3 millimeters, so it doesn't look stringy.
So there's no Teflon tube thing?
No Teflon tube.
All that, it just
freaking works, yeah.
So
change the diameter inside of your slicer.
But that's it.
That's it.
What's your retraction setting?
3 millimeters for this one.
Usually it's like 4 or 5 on this particular machine. Sometimes it can go up to like 6 or 7 depending on your Bowden setup. But
so I wanted to bump it up to 4 millimeters, and that's actually what we ended up doing. If you switch over to the next one here.
Yeah. This is the first print. It was kind of small. We'll show it off in the. This is bigger, right? So this is a bigger piggy.
Yeah, it comes with 2 different model sizes, so you don't have to shrink it and mess with the wall sizes. There is one tweak that they have to do inside their firmware. When you pause a print, because I ran low on filament, the gantry stops around, preventing you from adding more a new spool in there. Yeah. That's something they could tweak in the firmware. Just have it go all the way to the back of the.
So look what we did. We put it on a shower curtain rod.
Yeah,
and so it's like feeding up, down, under the printer, back up the printer,
and then over into the.
It's like a roller coaster, loop-de-loop. That's crazy.
So
and then up
if this isn't a testament for 175 working,
it works
flawlessly with retraction.
Now nobody might need to do that because look, if you have a Ultimaker or if you have a Taz or any other printer that has 3 millimeter, you're gonna have a lot of 3 millimeter spools. Nobody really needs to do this, and people. I think of people like Wayne, who runs Print and Z. He sells both filaments. It's in his interest to just have it. Nobody really needs to do this, but for us, it's just one of those things where we would like to use the filament we have, which is a lot of 175. So that's why Pedro's likes to change it up.
Yeah, for us, for stocking more film, I don't want more SKUs to be added. More.
We are going to stock some more 3, but
Ninja Flex.
Yeah, because we couldn't do that. There's some
I'm pretty
cases
sure it's not
where
going to work.
We're not even going to try it.
Ninja Flex. I don't think that'll work on a Bowden.
No. So 3 millimeter or 2.85 millimeter Ninja Flex is actually really good. Yeah. So let's take a look at this print.
So here's a little piggy bank, penny piggy bank, and as you can see, it turned out phenomenal. 175 Bowden.
No cleanup.
No cleanup.
Just 2 different colors because we ran out of pink. We ran out of pink, and we had to battle with it. And
Oh, and some people were asking, where's the pennies come out? The bottom there.
Yeah, we didn't print the plug. We just put tape.
Yeah, just put some gaffer's tape on there. And there we go. If you want to print 175, confirmed, working, proof. All right.
Kirby's asking if we've tried PET on Bowden. No, we haven't tried any PET yet.
PCPET? No, not yet.
PCPET? Oh, okay. Polycarbonate? Not yet.
Yeah, we still want to try the ABS polycarbonate stuff out.
Yeah, Polymax. There's a lot of polys out there.
We also printed it on the M3D, and you can see here I should have lifted the retraction a little bit more on that.
Focus.
Come on. Did a lot better during rehearsal.
Focus. There we go. Focused. Nope, you moved it. We're lagging a little bit, sorry.
Okay.
It's just our CPU, man. All right, so it's not the greatest.
Yeah,
we know it's not. It's a challenging print, man.
Yeah. And of course, on the, get some tweezers here. I don't want to touch
We have a Micro Pig.
We got Micro Piggy printed on the Ember 3D printer.
From Autodesk. Piggy printer. It's so thin, and Pedro doesn't want to touch it because he didn't let it cure.
Fully cure, yeah.
He wants to...
Anytime I look at any of the resin prints, I feel my hands become sticky.
Yeah. Come on, focus.
Focus. You get the point.
Piggy, high quality.
High resin, tiny piggy.
Doesn't fit any coins though.
Yeah, I think the coins are bigger than any of the slots.
Yeah. Just to test. All right, and that was our piggy segment.
We will try to get these in stock, the Sigmas in pretty soon. So definitely look out for those. You can use whatever the coupon code is during that time.
No, a penny doesn't fit, Kirby. And that doesn't fit.
No, the penny's bigger than it. Cool. Get 10% off your order. Get filament, the new Ninja Flex, and the regular Ninja Flex. I think we'll start stocking the 3mm again because it works really good on the Bowdens, or the Sigma. Doesn't work. The regular doesn't work as good on the Ultimaker. You just have to print like super slow. But the Cheetah works like a champ on the Ultimaker. And
Pokemon Go, everybody.
Some dual extrusion with Ninja Flex. So this is Cheetah and the regular Ninja Flex on there.
You want to do overhead?
Yeah, we'll do overhead.
This is next week's project? I don't know.
Whenever we're done with it, yeah. Just got to do some tweaks to the inner part of this.
Everybody's rushing to make Pokemon Go stuff.
Unfortunately, this is only going to be for the iPhone 6 Plus, since that's all we have here.
I want to remake this anyway in Fusion, because this was made in 123D design.
Yeah.
So there really aren't any like adjustable parameters for it.
Yeah, so Phil wanted a black one, but over the camera doesn't look too bad, but from far away, the color contrast between the white and the blue is a lot better.
It's cute.
But
so cute.
Came out great. Yeah, we'll release these.
Team Blue, Team Mystic. Whatever. I don't know. I need to
get
on it. I need to play.
We still need to download the app because there are more projects that will definitely benefit.
It's going to be
we
Pokemon month. Pokemon.
Yeah.
Lots of Pokemon. All right, so Pedro's feeling better, I hope. What's next? That was Shop Talk, right? It was all shops?
We talked about the Other Mill Pro, CNC on that. All right, let's jump into this week's Q&A.
All right, Q&A.
Or do we talk about... No, there's no community make, sorry. Q&A.
Yeah, Q&A, cool. All right, if you have any questions, save them up, and we'll answer them in just a moment. We have some queued up ones. And yeah, let's do the Q&A. First up, Blue for Life Blue is asking, do you think the Raspberry Pi camera and the Raspberry Pi Zero would make a good low-cost body cam solution for police? I mean, it kind of depends on your battery. So the battery that we have for this project is a 500 milliamp. I guess you could upgrade it or add like a USB big battery bank. Or maybe if it was a dash cam, you could plug it into your car, like USB going to your car. DC. Is it DC or AC?
For the car?
Yeah. DC? Or is it AC?
I don't know.
Anybody, let me know. Maybe, probably. What do you think? Yeah.
What's the question?
Does the Pi cam make a good body cam for police?
Oh, I mean, you just have to, you just need power.
Yeah. So battery. Figure out the battery stuff, and then you can mount it wherever you want. Is it durable and rugged like a GoPro? Probably not. That's what you're paying for. So, yeah, options. Cool. That's my thought. Next one. Wait, was that the... That's the next one, yeah. This guy's trying to troll me. Will you troll you? Does it take videos or just photos? The Raspberry Pi Zero wearable camera. So by default, the shell script does do photos. It's a time-lapse camera. You can disable that and add something, or add the Raspberry Pi video capture feature, which I think you can capture video. If not, then you can do like some live streaming to it, live video feed stream using JPEG Streamer. We have a video on how to set that up. Tony set it up for his cat laser project, and I set it up for Octoprint. So 2 different things there. Next one is about the magnet bottle holder. He thinks it's a good idea, but he's not too confident that the tape will hold. Guess what, folks? It's still holding up really well in our fridge. We still have the exact same stuff on it. Not balls, but like pickle jars and olives and some other stuff. It's kind of heavy. I don't know. It's like 5+ pounds.
It's about 10 pounds with
10 pounds?
On there, yeah.
Holy crap. And it's still holding up.
Yeah, so we usually do these projects like a month before, and it's been holding up for a month. So yeah.
3 months.
Yeah.
1 year ago. It's been holding up for 10 years. It's like that light bulb that's been holding up for 100 years. It's still holding up, guys. It's still shining. All right, next question is, hit the up button. I can't pronounce your name, Russian fellow, I believe. Why so hot on the Biggie print? Why do you print so hot, man?
Maybe it's the AC, but anytime I try printing any lower, it usually clogs.
Really?
Yeah. So it just depends on what your environmental setups are.
Yeah. All right.
Yeah, just experiment and see what temperature works for you.
That's why so hot. Chris Sparks wants to know, was that 12 hours to print the Biggie? 12 hours, that's what it says. Yeah.
Started like at 10 a.m., finished somewhere around 10 p.m.
Yeah, it's printing at 60 millimeters a second with, I think the outline speed is like 80%, so it's even slower.
I think it's
than
actually
60.
50%.
It's really,
so every time it gets to the outer layer, it slows down to like 40 millimeters. So.
Well, if it's at 60 default, then it's at
30,
30 millimeters a second. We're printing at 30 millimeters a second. Yes, it took 12 hours. Mm-hmm. That takes a long time. It's a big print, and there's a lot of retraction. So, yep. All right.
Oh, that and then me fussing with changing out the filament.
Yeah, that's right.
It definitely added some hours.
Okay.
Some little bit
Variable.
of time to it.
Okay. So Patrick is actually is from Formi, which is
the resin that we used
company
on this
that makes resins.
Pagoda printer for last week's time lapse.
Pagoda.
Tuesday.
Yeah.
So he's actually pals with
Mike Dole.
Mike Dole, who does a lot of our injection molded designs
for our Raspberry Pi cases.
Mm-hmm.
Yeah.
And he reached out and was like, "Hey guys, one of my buddies is making resins.
Y'all want some?
You want to try it out?"
So the cool thing about Formi type resins, it's just affordable. I think it's like 30 or 40 bucks or 50 bucks. Something like
it's like $49.
Yeah.
It's like half the price of what a resin.
It's usually $100 for a liter.
130, yeah.
Yeah. So this is some good not entry level, but good quality, affordable resin for you folks that do the whole SLA, DLP, SLA type thing. So there you go.
So
thanks, Patrick.
Mike Dole has an Ember. I forget what he uses it on, but probably a lot of the curvy designs for the Raspberry Pi cases.
You gotta be very specific. It's a small build, very small build.
Yeah.
Smaller than the M3D.
Yeah.
Tiny, tiny. Good stuff. Thanks, Patrick. Next one. This was from George Rubles. Just a tip from experience: look into a fly cutter and a spoiler board. If you have any questions, let me know. Yeah, so I think he's talking about the CNC machine that we have, the other mill. So the other mill does have a spoiler board. It's just made out of aluminum. And the reason why I don't use the spoiler board, I mean, that is the spoiler board, is a little aluminum bed. The reason why I don't add another thing is because then it reduces my thickness. The other mill only has a Z depth, like a cutting depth of like about 1.5 inches or so. So I don't want to reduce any because like when I was cutting out some bigger pieces of wood, I was just about on that threshold mark of like getting too thick. So adding any more to that, you know. So you just have to, since the other mill has some nifty probing features, it knows exactly how far away it is from the bed. It can accurately not scratch up the bed. And I haven't scratched it up on the other mill Pro. I did scratch it up on the other mill, the
non-pro.
The non-pro.
You have some nice little
because I was
in there.
exactly. Because I got the depth wrong for my tape. So as long as you have the right depth of your tape, you can offset where your part is or where your material is. So that's just a really good thing.
There's a tip for you.
Well, yeah, the other mill is kind of special. It's not like an X-Carve. You know, it's got a little bit more of a nicer.
That's what it costs
handling.
more.
Yeah, better software. Thanks, George. Next one is from John Osborne. You guys should do a microbit project. Yeah, we're trying to get some. They are hard to get. It's like Pi Zero. Are they real? All right, thanks, John. Miles wants to know, is there a video walkthrough of the Pi time-lapse case? I haven't done one yet. I'm taking a hiatus on Layer by Layers, but I'm inspired to start doing some more. I want to do a new series on CNC cam tools inside of Fusion.
Want to know how to generate the G code.
Yeah, I think, well, I'm learning as myself, so I think it makes sense to do that up. So yeah, there you go. Winnie Touch wants to know, he's trying to design a button PCB using the Rev B PCB that he found online. And he just has a question about how does this one close the circuit, because he knows that you need a ground pin and then a GPIO pin to close the circuit. That's a standard way to close the circuit for buttons especially. So this one's a little bit, it's not different, it's pretty much the same. So there's 2 ground pins on the top header area of the PCB, and then all of the buttons are linked through a trace. So you probably can't see it because it's like hidden by the mask. but they're all they're all in series, routed to ground, all the buttons, and then there's just 2 ground outs that goes into 1 ground of your Pi GPIO header. So that's how that works. Yeah. Now there's 2 grounds because one is for the main set of buttons, the 4 buttons, and then there's another ground if you want to ground a 3rd button, i.e. the shoulder, the right shoulder, and the left shoulder buttons. So that's why I have 2 grounds. Yeah. Hopefully that answers your question. Next one is from Russell Grant. He's working on a LED drum set type thing that reacts to sound. Basically, the project that we set up is specifically coded for a microphone input, a electret microphone, and he wants his piezo because it's a better solution. Because when you have it in actual real world, that sound is everywhere, and no matter how low you go, you're going to get sound. And if you're playing, they're all just going to go off.
Super loud. Yeah.
So we know about that. Hopefully we can get working on that. I actually want to ask Todd, who's working on Adafruit IO, if he wants to give that a shot of getting an analog piezo to work.
He's actually working on a model for a fully 3D printed drum set, so that might go perfectly with that.
I think so. Cool. So thinking about it. Next one is from John Gonzalez. So John Gonzalez, Jay Gonzalez, sorry, came across some issues using a Raspberry Pi 3 and Retro Pi. Oh, and obviously the Adafruit Pi TFT. So there is a little bit of a bug that when you exit Emulation Station and you try to go into the terminal, it actually won't display. It stays black, and there's this weird map TV02 FB0 text that gets displayed in the top left corner. So that's just one of the things that's weird with the Pi Zero. It has a different kernel, so some of the frame buffer tools aren't fully baked. They don't fully work. It works enough where if you don't exit Emulation Station. And then when you go into RetroPie settings, like Wi-Fi, for example, it stays black. So I don't know what's the issue with that. Maybe frame buffer tools will get updated. I'm not sure, but that is one of the problems that you will encounter if you want to use a Pi 3. That's why the Pi Girl 2 kit ships with the Pi 2, because we know it's proven to work. So that's just one of those things. If anybody knows, let us know. So it's one of those caveats, I guess, with new hardware.
Yep.
All right. Next one is from John Paul Hotman. He just wants to clarify that the FAA registering a UAS is because they are tasked with registering all aircraft. Therefore, they are not violating Congress's 2012 mandate, that they are not regulating hobby pilots. However, the UAS registration system implemented doesn't actually register drones. It registers the pilots flying them. We know that. We just wanted to sort of cater to the first search results in Google. If you type in how to register.
No, it's how to, and it auto fills in with how to get driver's license, how to register your drone. I think it was
really?
The third thing.
Right under driver's license.
Yeah.
So everybody's searching for how do I register a drone. Mm-hmm. That just seems to be the term that people are searching for. They don't know that you're registering yourself. So that's why we figured we'd name the video
They just
that.
want to hopefully be legal.
Yeah.
So, yeah.
So that's why we did it that way. We know about it, but just letting people know too. Yeah, just to cater to the search terms. Mm-hmm. All right, next one is from Patrick Connor. This is about the 7-inch portable Pi. If the case dimensions are extended so that the edges of the screen are not hanging over the edge, will it still be able to clip into the display as long as the proper editing is done in Fusion 360? Yeah, it's just the problem is you'll have more depth. Like if you go around the whole bezel, then your ports are even more deeper into your case. So you have to
pretty deep as it is.
Yeah, so you can do it, but then you have this whole
little ribs that are on the inside. I mean, you just want to keep that where it is so it can clip on the inside.
Yeah. One of the decide decisions, do I really want to have this huge gap of nothing here?
Yeah,
in my case,
and the gap is short enough where it doesn't make any sense to make any extenders that will go to the reach to the
okay, but give it a shot. I mean, walls, it's all there for you to test and play with. All right, next one is custom controllers. He basically wants to know what's a better software for the M3D instead of the official software, slicing software. So, it used to be called M3D FIO. That's the Octoprint plugin for M3D. But I think, we're not too sure, but the folks at M3D probably had to tell Mr. Donovan to change the name of the plugin to something else, because people think that the M3D FIO is like from M3D, the company. So they have to try to protect either their trademark, or maybe they're getting an influx of people saying, hey, I tried M3D FIO and it drove into my bed. Can I get a replacement? It's like, well, we don't support that. We're M3D. We make our own software. Please change the name. So Donovan has changed the name to M33 FIO. Mm-hmm. And he did say in a Thingiverse group that he was no longer going to develop anything for it. But since then, he has done 2 updates?
About 3 pretty big updates. So definitely go check those out. And that's what his question is, what other software is out there.
Yeah.
Check out
M33 FIO.
M33 FIO.
That's the name of it now.
So you are going to need Raspberry Pi, and you can slice with the Cura plugin that they have for that.
Engine.
Just drag your STL in there.
It's great.
And all it works perfect.
All right.
Check it out.
It's just our M3D update. All right. Miles asked another question. He's looking for the Pi 1.3 mechanical drawings. He sees the Pi Foundation has, but if you tweet at them, I think they'll upload it. They're kind of do it per request. So try that a shot. I did look for it myself. I couldn't find it, but I did find the Pi Camera 2.1 version. That is up there, so you can check that out if you want to use the camera. If you want to make an enclosure for the camera, but basically Miles is just trying to accommodate for the slot, making built-in support for the cable and such. So yeah. You just got to ask them. I think they do it per request.
Yeah.
Yep. All right. Next one is from Miles Van Dyke. How soon are we going to make a Pi 3 Super Game Pi 3? Well, as soon as we figure out that little issue with Retro Game Pi, then I'm not sure. So it's on hold for now. Yep. Got to figure out the software stuff. All right. That's all the questions that were queued up. And we're going to do some real questions now, or some live questions. Man, I need to drink water. I'm out of it.
So Tyler is saying that for the car, it is DC power.
Yes, DC. Awesome. Noted.
Phoenix is saying that we should 3-print a 3D printer and print a 3D printed printer with a 3D printed printer on the real 3D printer.
Printerception?
Printerception.
Sounds cool.
Kirby's saying that his Lulz bot failed twice in trying to print the Piggy.
Really?
Piggy bank.
Did you notice that we use support for the nose? Otherwise, it didn't turn out too good.
Might have been the retraction. Maybe slow down the retraction speed on it.
Yeah. Well, hey, we printed this at 30 millimeters a second, guys. So.
Well, that was just for the outlines. The rest was
yeah, but there's
60.
nothing but outlines. There's no infill.
I believe you are right.
Man, it took 12 hours to print. So print slower. Print's better, I guess.
10101 space is saying TV Be Gone, Watch Edition, yes.
Yeah, that was the earlier comment. Whew, we made it through an hour, Pedro, and you're still alive.
Projects.
It's not a question.
Oh, the layer shifted base twice at the same spot. Huh.
Oh. Why?
It's not the model, so... Oh, maybe the Z, we've had Z shift problems before, but it was like on the Type A. It turned out to be the
voltage on the voltage,
yeah.
bot steps? Really?
The E steps.
What is it, just like to change on Tuesdays? Like, what? That's weird, man. Sometimes you get Z shifts and it's like, why? For long prints, I guess it can happen.
Oh, okay. Might have been too hot with no AC, so it might have curled up and caught.
Oh, yeah. That will move your head. Mm-hmm. I've had that happen on a printer bot play.
A strike, where the nozzle hits it and moves it.
Oh, the Mini printed out really good though.
Oh, cool. I think that's it this week.
Yep. All right, folks. If you want to support the show, you know how to do so. 3D Doll will save you 10%. 3D doll.
We got some really cool new items
we got some
in the
new
shop.
joysticks that I'm really looking at.
So we've been waiting on these for a while to make a little portable arcade.
Yeah.
A little bit bigger one than the one Phil B made.
Yeah, I'm kind of tired of making RetroPie projects that use the Adafruit Pi TFT, because the Adafruit Pi TFT uses these special frame buffer tools, and they're kind of slow. I really like HDMI, because then you don't have these weird problems like we have with the retro game Pi 3 and the Adafruit Pi TFT. So it'd be really nice to use one of the like the 7-inch screens, or maybe even the 5-inch screens that has a built-in HDMI driver, and then a nice cool little joystick and some real arcade buttons, and you got like this nice fast HDMI, full 60 frames. Yeah,
check those out.
That'd be really fun.
Nick Faro is asking, are we gonna have Bluetooth on the watch?
I haven't looked if an Adafruit Feather. Adafruit BLE Feather would fit. If it might just take up the whole damn thing, because there's not a lot of space in there. But it does have charging built in. Maybe you can fit one NeoPixel in one Feather, and that's it.
Yeah, we'll play with it.
Yeah, I haven't even tried that. I need to try that. All right.
Good call, Nick.
Good call, Nick. Thanks. All right, folks. That's it for the show. If you guys have any questions, drop them down in the comments below. Be sure to check out this week's project.
Yep.
Give this video a like or a comment. Well, you've already commented. Thank you guys for joining in the chat room. We really appreciate you guys tuning in live here. And thank you guys on Twitch as well as YouTube. Cool stuff. All right, that's it. Everybody wish Pedro well wishes so he gets better.
I gotta go make some more tea this time instead of coffee.
I'm dry mouthed. All right, guys, thank you so much for tuning in. We'll see you tomorrow.
Oh, actually,
wait, not tomorrow. Next week.
Yeah.
Oh, wait.
Tonight we're going to be on Punish Props with Bill Doran, so check that out. We'll be showing off a lot of the cosplay projects that we've worked on, like all of the like the guns and all the props that have electronics in them.
Go to twitch.tv/punishedprops. We'll be there at 8 p.m. Eastern Time or 5 p.m. Pacific Time. So he's offline right now, of course. But yeah, check out Bill Doran. He's got some great content, awesome cosplay stuff, and he has a 3D printing series on how to use 3D printing for cosplay. So there you go. Check him out. Cool. All right, guys. We'll see you there. Be sure to check us out later tonight then. All right,
see you guys.
That's it. Bye, everybody. Remember to keep on making.